It seems like it's unrelated, but we're going to start talking about something called pressure today. Most of you guys probably think pressure has something to do with force, and you'd be right. What I usually talk about these days is prom, which nobody got to go to. One, because you're freshmen, and two, because there were no proms this year. But if you imagine walking around taking pictures for prom, and when the ground is a little bit mushy like this, if you're wearing heels, your heels kind of squish into the ground. But if you're wearing flat shoes, your feet don't sink in as much. Or to an extreme situation, if you're walking around in deep snow, your feet kind of crunch through the snow and it's hard to walk through. But if you put some snowshoes on, then it's easier to walk on top of the snow. And this is pretty much due to something called pressure. So when you talk about pressure, we're talking about force and we're talking about pushes, but what you're doing is you're dividing that force by the area that you're applying the force over. So if you have your weight as your force and the tiny little end of your spiked heel as your area, then there's a lot of pressure and that will force your shoe into the ground. But if you've got snowshoes on, then your weight will be divided by a larger area, and so the pressure will be smaller, and you're allowed to kind of walk on top of the snow. What if we had a container? Hi, I'm a container full of water. We probably need a better drawing. Yeah, a better drawing. There we go. A container full of water. And you say, hey, what's the pressure down here? At the very bottom of the container, what is the pressure? So pressure is going to be the force divided by the area. And what is the force? Right? The force is basically the weight of this water. So the weight of all this water up here is applying force to the bottom of the container. So the pressure is equal to the force of gravity divided by the area at the bottom of the container. And since the force of gravity is equal to m times g, we can say that the pressure is equal to m times g divided by the area. Well, how am I going to find the mass of that water? We're going to cheat a little bit, and we're going to say, hey, I hope you guys know what density is. Density. That's a Greek letter rho. You can look it up, R-H-O. Density is equal to broken heart. M over V, right? So density equals M over V. That means that the mass is equal to the rho times volume of the container. So the pressure then becomes rho times volume times G divided by the area at the bottom of the container. I'll bet some of you can see where we're going with this right now. So the volume of this container, how do I calculate the volume of a solid? Well, I take the area of the bottom times the height, and now I've got the pressure is equal to rho times the area times the height times G divided by A. And hey, it doesn't matter what the shape of the container is. Now we can see that when we have this liquid-filled container, the pressure at the bottom of the container is equal to the density of the liquid that's inside times the height of the liquid times the gravitational field strength. And you're going to see a whole bunch of demos now that have to do with water. And the cool thing about water is the density is always going to be the same. And we're doing this at the surface of the earth, so G is always going to be the same. So what we're seeing here is pressure is directly proportional to the height of the water in the container, and that's something that you should remember as you're watching demos for the next activity.